Okay, let's finish section R1 by doing some operations on polynomials. Okay, so example 2 here, perform the following operations and simplify. Okay, so parentheses around that first one are not really necessary. It's kind of just to show that that's a polynomial sitting by itself. And then we're going to use just those properties of distributing and combining like terms. So for this one, we can kind of just drop those parentheses on the first one. And then be careful here, this -3 has to distribute. So the whole -3 would distribute onto those two pieces here. So for the first one, I'll go ahead and just drop the parentheses. There's no extra distributing happening in there. So this one we can go ahead and just drop. Right here, distribute. So -3 times 2x is -6x. -3 times -5x to the fourth will become plus 15x to the fourth. Okay, and then make sure that whenever you see instructions for simplify, go through and simplify as much as you can. So combining like terms, remember that it has to be the exact same exponent and the exact same variables. So for this one, there's only x involved. And let's see, I'm thinking we've got x to the fourth and x to the fourth. So 3x to the fourth plus 15x to the fourth is 18x to the fourth. And then looking through at the rest of these, we've got a cube, we've got a regular x, and we've got a number, and none of those are like terms. And so we're pretty much done as long as we write down everything else. And it's typically a good idea to write in descending order of the exponents. And so what I mean by that is I purposefully wrote it with the highest power first, then the next highest power, then the next highest power, and so on. But the order technically doesn't matter. It just usually looks nicer if we write it in this descending order. Okay, for this one, you got two polynomials multiplying together. Okay, so this is going to be a distributive property, but there is a nice little strategy for how to distribute something like this out. And maybe you've seen FOIL. Okay, and FOIL is a little acronym that helps us remember to do all of the distributing. So the F says the first times the first. So 3x times 2x is 6x squared. The O is for the outer term times the outer term. So that's the 3x times the -5, so that's minus 15x. The I is the inner term times the inner term. So that's 2 times 2x plus 4x. And then the L is for the last term times the last term. So 2 times -5 is minus 10. Okay, do any combining of like terms that you can. 6x squared doesn't have anything in common, but those two x's do. So minus 15x and plus 4x, we get minus 11x, and then that minus 10. And that would be the answer there. Okay, FOIL. Okay, so when I refer to FOIL, it's kind of like this silly little acronym that helps us remember how to distribute this all the way out. For part C, this is a 2-term polynomial times a 3-term polynomial, or a binomial times a trinomial. Okay, FOIL technically doesn't really make sense because there's like a middle, there's first, outer, inner, last, middle, all kinds of crazy stuff. So sometimes I just say that this is like a huge FOIL, a super FOIL. So I still want to think about it as each one has to multiply onto each one. So x times x squared is x cubed. Then I have to go on to the next one. X times -3x is minus 3x squared. And then that one times the last one, x times 4 is plus 4x. Okay, then I move over to the 2 and I make sure that I distribute it onto everything. So 2 times that x squared is plus 2x squared. 2 distributed onto the next one, minus 6x. And then 2 distributed onto the last one is plus 8. So it's kind of like a super FOIL or a double FOIL or something like that. Okay, go through and combine like terms. Looks like we've got x cubed. We've got 2 different x squareds, minus 3x squared and plus 2x squared. So that's minus 1x squared. Okay, we don't need to put the 1 if the coefficient is a 1. Okay, then we've got 4x and minus 6x for minus 2x. And then there's plus 8. Okay. All right, for this last one, so we see that this is a binomial that's cubed. When I say binomial, I mean that there's 2 terms in there. And so it's really tempting to want to just cube each piece on the inside, but we have to be very, very careful. Just like in that first example we did where it was 3 cubed, what that really means is it's that thing times itself 3 times. So we have to write this as 2x minus 3y times itself 3 times. Okay, that's what cubing means. So if you ever see a binomial or a trinomial or something like that, where it's a whole bunch of terms on the inside that are like adding or subtracting, and it's raised to a power, you have to multiply it all the way out that many times. Okay, it's a little bit of a hassle, but that's what it means. Okay, so how do we deal with this? Well, the best way to deal with this is probably just section it off and try to do a couple pieces at a time. Okay, so the way that I usually like to do it is with all of this multiplication, we can kind of just like section this part off. And it kind of doesn't matter which section you want to do first, but I want to just grab 2 of them, and then we'll just do a regular FOIL. We'll combine our like terms, and then we'll distribute the other one in with a super FOIL. Okay, forget the informal terminology, but that's the way that I think about it. So let's go ahead and ignore that one in the front, and let's go ahead and just FOIL this out. So 2x times 2x is 4x squared. 2x times negative 3y minus 6. X times y, those can't combine, so they just multiply together. Okay, in here, negative 3 times 2x is another minus 6xy. And then negative 3y times negative 3y is plus 9y squared. Okay, don't forget there's still this thing out in front here. Okay, let's go ahead and combine like terms in here if possible. So I'll write this one again. So we have 2x minus 3y sitting out there. And I'm not going to use brackets anymore. I'll use parentheses. We have 4x squared. Notice that these 2 middle ones are the exact same variables with the exact same exponents on them. So they can combine as minus 12xy and then plus 9y squared. All right, now let's do the super FOIL where we have to distribute each piece onto each piece. So 2x times 4x squared is 8x cubed. 2x times negative 12xy, be careful, that's going to be negative 24. There's 2 x's multiplying together, so that becomes squared. And then there's the y. Okay, and then the 2x times that 9y squared is going to be plus 18x and y squared. Okay, then move over and do the next one. Negative 3y times 4x squared is going to be minus 12 x squared y. I typically kind of try to keep the same order of the variables. So I don't know, alphabetical order usually makes sense to me. So I'm just going to remember that the order of the multiplication doesn't matter. So I'm putting the x squared in front of the y for that multiplication there. It technically doesn't matter though. It just looks a little bit prettier, I guess. Negative 3y times negative 12xy. Okay, be careful. Negative 3 times negative 12 is plus 36, and then it's a single x, and it's y times y for y squared. And for the last one there, negative 3 times positive 9 is going to be negative 27, and then it's y times y squared is y cubed. Okay, I'm going to go through and see if there's any like terms, and it looks like the 8x cubed is going to be by itself. Okay, remember, for like terms, it needs to be the exact variables with the exact exponents. So let's see, negative 24 x squared y, and we also have negative 12 x squared y, okay? Those are the same variables with the same exponents, so those can combine as negative 36 x squared y, okay? And then similarly, 18x y squared with 36 x y squared, those are the exact same variables to the exact same powers. So those can combine as the 18 plus the 36 for plus 54 xy squared. And then there's that minus 27 y cubed. All right, so we did it. And that might be a way messier answer than you might have been expecting when you first looked at it, but that is what has to be done if you see that a binomial is raised to an exponent. You need to multiply it out that many times. Okay, so that finishes off section R1. Next, we'll be looking at section R2.